All right, everyone. Yay, we've reached proof 27 and 28. This is fun. We're having fun. What is our given? Our given on this proof, the problem we're trying to solve, is the measure of AEC equals 5x minus 15, and BED, where I wish I was lying in my bed right now, is equal to 3x plus 7. That is the problem. That is what to us? It is given to us. So I get to write given right here, and I've just gotten some free points for knowing that that was the problem that was given to me. What are we ultimately trying to prove, my friends? Always start with the end in mind. So what are we trying to look for? We want to know that the measure of angle AEC is 40. Thankfully, they haven't filled that in on this proof yet, so I get to, and I get to earn some points, some free points. I already know the answer. I am just trying to explain the process. So the measure of angle AEC is equal to 40, so I get to stop once I get there. Okay, so as soon as I find the AEC is 40, boom, my proof is done. We just want to work with the process. Okay, so how do I know that AEC, that's this one right here, is congruent to BED? Well, so look at your picture. What kind of angles do I know that these are? These are vertical angles. And we learned a theorem called the vertical angles theorem. Vertical angles theorem. I'll write out that whole thing. Why not? I've got room. Vertical angles theorem that says if two angles are vertical, then they are congruent to each other. So based off of our picture, that was some more information given in the diagram. Those are vertical, and thus they are congruent. Okay? So if they are congruent, what do we know about their measures? By the definition of congruence, because of this symbol, I get to change that to an equal symbol, and I know that the measure of angle AEC is going to be equal to the measure of angle BED. Why does that matter? Because now that I have that equal sign on there, I can substitute the expressions that were given in the diagram. So were the expressions that were given in the diagram, AEC is 5x minus 15, so I plugged that in. And then BED is 3x plus 7, so I plugged that in. What is it called when you plug something in? That is called the substitution. So many T's in that word, substitution. Property of equality. I substituted in the values. Okay. Now it tells me to use the subtraction property of equality. So when I use the subtraction property of equality to get to this next step, I'm going to go minus 3x and minus 3x. You could have also done minus 5x and minus 5x, but I'm a positive person, so I like to keep things positive. 2x minus 15 equals 7 by the subtraction property of equality. And so how do you get from step 5 to step 6? That's what we're going to put right here. How did I arrive at 2x equals 22? Well, you have to look at the step before and say, well, who moved? The 15 moved to the other side. So how would I do that mathematically? That would be the addition property of equality. They added 15 to both sides, which gave them 2x equals 22. So how do you bring it home in order to solve for x? I would divide by 2 on both sides, divided by 2, which of course is called the DivPo, division property of equality. If they just told me to solve for x, I'd be done. But they didn't just tell me to solve for x. They want to know that AEC is 40. So how do we get there? Well, we have an expression for AEC. It says that AEC is 5x minus 15. So now that I know that x is equal to 11, I can plug that in and substitute it in. So that's going to be substitution. Substitution. That is going to be our substitution property of equality. I substituted it in. And so when I substituted that in, I can then simplify it. 5 times 11 is 55, minus 15 is 40. I did that to one side of the equation. I simplified that algebra. And so 5 times 11 minus 15 gives me 40, which is what I ultimately wanted to prove. So that was proof number 27. Let's move on to the last proof. Last proof. Be excited. Let's cheer. You've got this. You can do this. You can do hard things, my friends. Let's look at proof 28. What is the problem we're trying to solve? Well, it's right here. Thankfully, they didn't write into the proof yet, so we get some free points. How do I know that? Because it is given. So what am I going to fill in? I know that from what they told me, ACB is this one right here, and angle BCE are supplementary. Those are supplementary. That's what they told me. So BCE is this one right here, star and heart. Okay? So there's the star. There's the heart, if you like to use symbols. What am I ultimately trying to prove? That the measure of angle BCE is 130 degrees. So that should be the very last statement that I reach, is that BCE, the measure of it, is equal to 130 degrees. Okay? So start with the end in mind, and then we're just going to fill in the process. When they tell you a vocabulary word in the given, you're going to use the definition of that vocabulary word rather quickly, because they don't just tell you that for funsies, okay? If they tell you that those are supplementary, they do that for a reason. What does that mean? It means that when you add their measures together, what do their measures add up to mathematically? What is that equal to? Their measures, their numbers, the values of those degrees. Well, because they're supplementary, they're going to add up to 180 degrees. So that word supplementary gave me that 180 number. Okay, so what do we know about those angles? Well, what can I substitute in now? Well, I know that the star angle is 5x, and I know the heart angle is 9x plus 40, so I get to plug that in. So I'd say, well, that means that 5x, because I have this equation, I can plug something into it, plus 9x plus 40 is equal to 180. What is it called when you do that? You sub things in. So they're actually telling you what to do on the right-hand side. So this is a proof where all the reasons are given, you're filling in all the statements. So now they're telling me, hey, what you need to do next, this is like the teacher telling you what to do. What do you need to do next? You need to combine like terms. So put your stuff that's alike together. What is 5x plus 9x on that row? 5x plus 9x is going to give me 14x plus 40 equals 180. What do they tell you to do next? Subtract. What are we subtracting from both sides? You'd go minus 40 and minus 40. So I'm going to do that real small, minus 40, minus 40. What would that give me? 14x equals 140. That was with our subtraction property of equality. That's how you got from the previous step to this step. Then they want me to divide to get to the next step. What would we divide by? Divide by 14 on both sides. So when you do that, you're going to get x equals 10 using the divpo. If they just said solve for x, we'd be done. But they actually want me to go back and plug it in to find the measure of angle BCE. What do we know about angle BCE? We have an expression for it. What is it? The expression for BCE is 9x plus 40. So I'm going to do 9 times the measure of angle BCE is equal to 9 times x. Well, what is x? X is 10, so I'm going to drop that in. 9 times 10 plus 40. Okay? And so that's substitution. I just plugged it into the expression I had. And then I just have to clean that up. What do I mean by clean that up? I mean simplify it. 9 times 10 is 90, plus 40 is 130. That is when you simplify. So that is our final answer, and that is exactly where I was trying to get in this proof. Yay, proofs!